Yeah, welcome back, or welcome at all, folks, to the first lecture in the first week here. So now, not the first podcast of the week, but the first podcast with some content, which is really related to the content of the lecture. So this week we will have the following content. In this podcast, we'll play a little bit the buzzword bingo. And then in the remaining podcasts, you will have a short recap of KDD1 and an overview of the KDD2 topics, and finally some recommended literature. So let's start with the buzzword bingo. So why are you here? Why are we here? Why are we doing that? What we are doing here, KDD2. So we are going to learn about methods for deriving patterns, deriving knowledge from data. And why should we do that? Of course, I shouldn't tell you too much about that, because we all know that we are gathering data, generating data and data. So we have this very famous saying, we are drowning in data yet starving for knowledge, because we are actually really drowning in data, but we sometimes have no clue how to get really some benefits out of this data. So we are starving for benefits, we are starving for knowledge, and that's just because we have so many applications where we have just tons of data, and that means that if we have tons of data, usually that going through that manually to analyze them is simply infeasible. So we have to come up with automatic methods for deriving knowledge, deriving information, deriving benefits. And of course, people have done that for the last couple of 50, 60, 70 years. And that's what this KD2 lecture, of course, is all about. So basically, there are two classes of solutions, I would say. The traditional statistics point of view, which, but I don't want to narrow down all the statisticians to just this first approach of descriptive modeling. But of course, most of the statistical community, statisticians, oh, that's a hard word for me, sorry for that. So most of this community, of course, is about describing the characteristics and the behavior of some data. Yeah, we typically talk about the data of observations, and we want, in that case, describe characteristics or behaviors or whatever properties of the data, more or less to understand the data, but not really to predict something. Yeah. But the step to predictive modeling is not that far, because many of these descriptive models can be used later on to predict, also have predictive power. So in the predictive modeling approach, you really want to predict the behavior of new data based on some model that can be a descriptive model, based on some model that has been derived from observations. That means from data you already gathered. And you probably know this term big data. It was triggered by a group of business administration guys. So some consultants by McKinsey came up with this term, characterized big data by 3 V's: velocity, volume, and variety. So they said that if your data set has at least one of those V's, it is big data. And that was a really hard point for the computer scientists. So this McKinsey thing came out in 2011, and at that time I think we had the 35th or even the 40th conference on very large databases. This is the flagship conference on in the database community, and that was I mean, people were dealing with large and big data for 40 years or even more. Yeah. And of course, big data, especially the database community, thought it is more a data engineering database task than a data analytics task. And of course, it's more a computer science task than a business administration task. But anyway, the McKinsey report was beneficial also for computer scientists, because it triggered really the need for managing and also analyzing large amounts of data, and also related fields like industry 4.0, industry 4.0, data lakes and stuff like that. All those concepts, all those buzzwords came up later on, and mostly they are dealing with this idea of managing and also mining complex data. So data lake is, I think, where most of the German industry and German companies are right now in. They are gathering data and just where should I put it? Well, just put it in the lake, in the data lake, and let's see later what we can do with it. Yeah. So here in this lecture, we are talking about what can we do with this, not how to put it in there and how to manage it there. So we are a step ahead of these things like data lakes and stuff like that. Anyway, so data science is considered a big hype right now. So data science is a new term in this canon here, yeah, and that was actually the answer, a little bit the answer of the computer scientists to the big data term of McKinsey. Yeah? There was this joke about, well, what is bigger, or what is more, big or very large? Yeah? So very large was this title of still the title of the conference, International Conference on Very Large Databases, and big data was the term by McKinsey, and the somehow ceiling point where people could, from both religions, I would say, could really arrange themselves with, was the term data science. And the most important point is, as we will see right in a minute, is that data science is considered to be a more general process, not only collect data or gain value from data, but just do it all together in one big process, as we'll see right in some seconds. So here's just the point that if you consider it as a more general process, then you are in a teamwork setting. So people found out that they cannot solve complex data science tasks by themselves, not the computer scientists, not the mathematicians, statisticians, and also not the business guys. Yeah, so you need all of those expertise, all of those sub-communities to really solve the data science use cases. And typically there is no data scientist in the term that really knows everything from all those surrounding communities. Yeah? So you may have a good computer scientist that has some good knowledge in mathematics and stuff like that, maybe also a little bit domain knowledge, but in the end, very often there are much more clever guys on this end, so what I want to say is that the very often cited unicorn of a data scientist is probably really a unicorn, or in other words, is not existing. So typically data science is a team effort. So and there is a new buzzword actually coming up, which is as old as the Greek culture, artificial intelligence. People, especially politicians, misuse, I would say, this term now as a synonym for data science, but that's not really the case, because AI is originally an extremely broad subject within CS. So you see it includes reasoning, problem solving, knowledge representation, natural language processing, perception, and stuff like that. Also learning, machine learning, and I think most of the people, especially politicians, think that it stands for machine learning. AI stands for machine learning. That's not the case originally, yeah. But very often people now mislead or misinterpret machine learning, or spell, so to say, machine learning and AI. Yeah, at least there is a major overlap to machine learning and data analytics, of course. Yeah, and the problem is that in Germany, AI has been misused for the whole thing just for deductive learning approaches for the last 30 years. Yeah. So in Germany, if people were talking about AI, they usually talked about deductive learning approaches, which is just one thing here, reasoning. Yeah. But that was the situation in Germany. There was a very strong deductive learning community, is still there, but and a very small machine learning community. So it's steadily growing now, the machine learning community in Germany. But just keep that in mind, that people, if they are talking about AI, sometimes just don't know exactly what they are talking about. It could be anything from here, but very often it's either machine learning or deductive learning. So the question is, what is the difference between deductive learning and machine learning? Well, that brings us to the question, how can machines learn anyway? So there are two basically different approaches. The first one is deductive learning, which uses a set of facts and rules, which is the knowledge base, to derive new facts by deduction, logical inference. So the learning is from the general knowledge bases, the general rules, to some specific facts that are somehow implicitly hidden in this knowledge base. Here's the example. We have a fact base saying of two facts, actually. The first fact is Krüger is German, and the second fact is all Germans have no sense of humor. And you can derive easily with logical inference that, well, if all Germans have no sense of humor and Krüger is German, Krüger has obviously no sense of humor. If the knowledge base is true, which is true here, of course, then the derived fact is also true. Yeah, that is fine. So if you have a very small, fixed and closed system that you can model with a finite set of rules, of facts that are definitely true, then you are in a 100% safe setting. Super easy. Yeah, but the problem is there's no real predictive power. So what if you want to derive the fact of I don't know, Donald Trump? Does he has a sense of humor or not? You don't know you don't have any facts about US Americans, so you cannot predict anything here. And that is different for the second class, which is inductive learning. So the opposite of deductive learning is inductive learning, and machine learning is actually an inductive learning approach, or stands for the inductive learning approach. So you use a set of observations, individual observations, to learn general facts. So the learning is completely different. You learn from specific things and try to derive general things. Yeah, so you can think of you see something in the world and try to explain the world out of those observations. Yeah, here's the example. We have 4 observations. Krüger's German has no sense of humor. Schmidt German, no sense of humor. Meyer German, no sense of humor. Blatter Swiss, no sense of humor. So the learned fact can be, or the generalization can be, Germans have no sense of humor. Maybe also non-Germans have sense of humor. So Blatter is Swiss. He's the only non-German. He has sense of humor. So there could be a rule derived from those observations that's saying, if German, no sense of humor. If not German, sense of humor. Well, so far so good. Well, usually we do not have all possible observations. Unfortunately, we only saw the 3 Germans that have no sense of humor, and only the one non-German that has sense of humor. So in that case, the derived rules are probably not 100% true, depending on what we have seen from what we have learned. That's extremely important. But the positive side is that we now have a predictive power. So if we know Müller is German, he or she has no sense of humor. And now we also know that Trump must have sense of humor because he is not a German, and non-Germans have a sense of humor according to our observations. Yeah? So you see those different approaches, and then there is maybe just a distinction between machine learning and data mining, which is just how you actually try to solve those problems here. So machine learning usually uses a kind of modeling or functional programming approach, and the data mining usually uses a more algorithmic or procedural approach.